Our discussion still moves on objects that move in motion, and we want to look at the first question from the story sheet. And this question says, a belt runs on a wheel of radius 44 centimeters. During the time the wheel takes on to course uniformly to rest from an initial speed of 1.6 rev per second. 29.5 meters of belt length passes over the wheel. Find the deceleration of the wheel and the number of revolutions it takes while stopping. So it's important to understand that what we're talking about here is objects that are moving in a circular position. And we did discuss to say for any object that is moving in a circular position, you're going to have a circle like that. Alright? And the different kind of forces that act on objects that move in circular positions. You might have a force that is acting to the center of this object, which is called the centripetal force. And then we have different parts of the circle. We have a line that moves from the center of the circle from that position there, moving on to the circumference of the circle, and we call that the radius. Okay, and then the other part also, when you joined from the center of the circle to the circumference of the circle, that's the radius. Then the radius plus the radius is going to give us the 2r, which now changes the name from the red radius, it goes to the diameter. All right, meaning that the line that moves from the circumference of one circle to the circumference of the next circle, passing through the center of the circle. So now for objects that now move in a linear position, just like the way we have objects that move in linear positions, you may have different kind of formulas where you have v1, meaning the final velocity, and you might have displacement, and then you might have velocity. It is important to understand that when you're talking about objects that are moving in motion, okay, in a circle, we refer to these objects as objects that are possessing a certain angular speed. If we're talking of it in position of speed, what do I mean? What I mean is you might have what we're calling linear positions. Okay, so you might have linear or tangential, and the other word that you might have here is angular. So when you hear the word angular, just know that the movements of these objects are in a circular position. So you might have displacement here, all right, meaning that you have an object which is moving in a straight line, because the meaning of the word linear is straight. You might have an object moving in a straight line, but when it comes to the circle, okay, what you are going to have there in a circle, what you are going to have there is going to be called angular displacement. When it comes to the velocity you are going to have for an object that is moving in a circular position is called angular velocity. So it is important for you to understand that. Usually it's the same thing that happens when you're dealing with different formulas. You might have a formula, remember those equations of motion. You have the final velocity being equal to the initial velocity plus AAT, meaning that acceleration multiplied by time. You might have the v squared, final velocity squared, is equal to initial velocity squared plus 2ax. This 2ax we're talking about here is the a is the acceleration which is happening for an object that is moving in a linear position, and the x there is a distance. Okay, but when it comes to objects that are moving in a circular position, things change. Okay, the velocity that we're going to have here is not going to be the linear velocity. What we're going to have there is called the angular velocity, which is represented by that omega. Okay, so this is angular velocity, the final angular velocity being equal to the initial angular velocity, then plus the acceleration now becomes angular acceleration, represented by alpha. Then the time never changes for any equations in motion. Equally for the other part here, you're just going to have the final angular velocity squared being equal to the initial angular velocity squared plus the 2. Then the acceleration now moves from the linear acceleration, it becomes the angular acceleration, which is presented by the alpha, and then the x there is what the distance. So when it comes to the displacement in terms of angular for objects that are moving in a circular position, we call that as angular displacement, which is presented by theta. All right, so this is what you have in this position. So now let's collect our data from this question. This question has given us the radius. Okay, we've been told that from this question we're having the radius of, okay, it is important to take note of the data that you've been given so that you're able to attempt your question. So important note. What have we been given here? We've been given the radius, and the radius here is 44 centimeters. What else has been given in the question? Okay, during the time the wheel takes to coast uniformly to rest, alright, uniformly to rest from what? Uniformly to rest from, so these are centimeters, let's not forget that. And then we're saying that during the time the wheel takes to coast uniformly to rest, so meaning that the final angular velocity that we're going to have here is going to be equal to 0. Okay, and then we have from an initial speed, meaning that the speed that we're talking about here is the angular speed or the angular velocity. The initial angular velocity is going to be equal to 1.6 rev per second. All right, so this is the data that has been given. So the first part of the question is asking us to do what? Find the deceleration of the wheel and the number of revolutions it turns while stopping. So how do you find this number of revolutions? So we need to understand that what we've been given in this question is the linear distance. Okay, the linear displacement has been given as 29.5 meters. Then we've been given the angular velocity, which is 1.6 revolutions per second, which was the initial speed, okay, of the wheel. The other thing that has been given here is the radius. So we've collected our work. What are we supposed to do? Remember that there's a formula. When you get back to the preamble of this topic, we talked about formulas that were relating the linear displacement to the angular displacement, meaning that under linear displacement you're going to have the distance as s being equal to theta multiplied by what? By the radius. The radius has been given to this question. This question has 44 centimeters, but you can't keep that 44 centimeters like that. You have to convert it into meters, and you know that the conversion factor is 1 meter being equal to 100 centimeters. So when you convert that, you're going to have 0.44 meters from 44 centimeters. So what is the value of the distance that was given? We're given 29.5 meters. What is the value of the theta? That is what we're looking for here. We're trying to look for the value of theta, and when we find that theta, which is going to be in rad, we're going to convert that rad into the number of revolutions. So theta here multiplied by the radius of 0.44. What are we going to have next? So what are we going to do here? We're going to divide over 0.44. On the other side, we're going to divide 0.44. So the value of theta we're going to have here is going to be in radians. Theta is always in radians. We're going to have 67.05 rad. So what you have here is the angle in radians. So when you get back to the question, of course they were asking for the angle, and you've seen that physics, they provide you with some answers. So the value of the theta has been given as 67.67 rad. So they want us to find the number of revolutions. Let's find that value. If it's going to be 10.7. So how do you do that? So we already have the value of theta, and you know that a complete revolution is made up of 360 degrees, meaning equal to 2 pi in terms of rad. So one revolution is equal to 360 degrees. If you have been taught to convert those radians or revolutions into degrees, and then this 360 degrees is equal to 2 pi rad. Okay, because pi is equal to 180 degrees. So one rev is going to be equal to 2 pi. How many radians are we having here? We're having 67.05 rad. I'm trying to find out the number of revolutions because that is what the question is requiring me to do. So how do I go about the question? This becomes y times 2 pi. I'm going to have 2 pi y being equal to 1 times 67.05 is 67.05. Divide over 2 pi. Divide over 2 pi. And the value of y I'm going to have here as the number of revolutions. Okay? The number of revolutions I'm going to have here are going to be equal to, so when you divide 67.05 divide 2 pi, I'm having 10.05 revolutions. So there we go. There you have it. So now, when you get back to the work, you discover to say the 10.7 rev were the number of complete revolutions that were found in the question. Not so different from what we're having. It's equally the same thing. So what were we doing here? The first thing we did was to find out what is the displacement. The displacement was 29.5. It was linear displacement. What formula was relating linear displacement to the angular displacement or anything to do with the theta? It was S is equal to pi r. The r is for the radius, then the theta is for the angle that we're looking for there. That is what we've done. Then the second part of the question is asking us to find the deceleration. So out of the work that we have been given, how can we find the deceleration? How can we find the acceleration? Because you know that the opposite of acceleration is deceleration. If an object is accelerating, when it stops accelerating, starts now decelerating, then the value now becomes a negative value. So the negative acceleration is called deceleration. So out of this that we've been given, we only have the final angular velocity, the initial angular velocity. What other thing are we having? We're having the distance, which is 29.5. We're having the angular. What else are we having here? We're having this one is called the angular displacement that we found. So how can we use this work to get us something? This is angular displacement. Now this angular displacement is in rad. So now since the formula has been given in, okay, so now since the angular speed has been given in rev 1.6 revolutions per second, mean that for me to find out what that acceleration is, I'm going to use 10.05 revolutions because this is in rev. It will align with the SI units of the distance that have been given, of the velocity which has been given in the question. So now, the question I'll ask us here is, we have been given that the final speed, okay, is equal to 0. The initial angular velocity is equal to 67 1.6 rev per second. What else have we been given? The value of theta here that we found as 10.5, and this the value of theta is what we're calling rev. Okay, yes, so this is rev per second, and rev per second, this value of theta, sorry, not rev per second, but this is rev. These are the number of revolutions. Okay, we have them as 10.05 revolutions. So what formula can we use with a given work that is here to find out the deceleration? Remember that when you get back to the equations of motion, you have this formula here. You have the formula which is the final velocity squared is equal to the initial velocity squared plus 2 acceleration. Now in terms of the objects that are moving in a circle, we're talking about angular acceleration multiplied by the value of theta. So now in this question, what are we having as the final velocity? The final velocity is equal to 0. Now this velocity is not just any velocity. This is for an object that is moving in a circular position. So this is angular velocity. And what we're having here is a 0. This is 0 squared. What we're having here is 1.6 rev per second squared. This is plus 2. This is, remember there's theta here, plus 2. The value of acceleration that we're looking for here is that, which is the angular acceleration. Then the value of theta that we got were how many? That is 10.05 rev. 05 revolutions. So now what are we supposed to find? We're supposed to find the value of theta. 0 squared is a 0. Okay? 1.6 squared. Alright? So now we are having 1.6 squared is what? So we're supposed to find the value of 1.6 squared so that you know the exact value of the acceleration that you're going to have in that particular kind of equation. So 1.6 times 1.6 is going to give us 2.56. Then you multiply 2 times 10.05. The value you're going to have there is 20.05. 0.01, then remember there's theta there. So now what do? You collect the equal sign. This is a 0, this is 2.56, so this one can cross the equal sign, becomes negative 2.56, which is equal to 20.1, then the alpha, or the angular acceleration. So divide 20.01 and divide 20.01. So what is the value of the angular acceleration? The value of the angular acceleration becomes, this is negative 2.56, divide the answer. It becomes negative 0.12, okay, 0.12 rev per second squared. Just like the way we have it in linear motion, acceleration is the SI units for acceleration is meters per second squared. So when it comes to an object that is moving in a circular position, we're talking of it in terms of rev. So this becomes negative 0.12 revolutions per second squared. So this is how you find the deceleration from the question, and this is exactly how you find the number of revolutions. So remember to know the conversion factors. It is also very important that you relate the equations of motion, linear motion, to the equations of the objects that are moving in a circular position. Remember, when an object is moving in a circular position, we're defining the movement of those objects as angular. So we can have angular velocity, angular acceleration, angular displacement, and so on and so forth. But when it comes to linear equations, they really, you have to maintain the velocity, you have to maintain the acceleration, and the other quantities that we can find. So this is how you're supposed to go about the question, and you can check that the answers that were given in this question is what we found. We found negative 0.12 revolutions per second squared. The value of theta we found as 7 rad, and the number of revolutions that we got for 10.7 revolutions. Thank you so much for your time. Look forward in the next session.